In a new language, we are going to learn the language of chemistry. Similar to other languages, we're going to use characters and symbols in order to communicate what's going on in chemistry. Moving forward, we should be able to look at a chemical formula and understand what the information means. We should be able to look at an element symbol and be able to figure out what the element is. Also, we should understand the phases or physical states of matter by a formula. We should also be able to look at a chemical reaction and interpret what happens. And we're also going to be able to write chemical reaction from formulas. And we should be able to predict what we will observe if we are looking at a chemical reaction. So, chemistry is communicating. This is something you guys are going to want to record. All of the elements are on the periodic table, and each is represented by a symbol. The symbol can be one single capital letter, such as nitrogen. The chemical symbol for nitrogen is the letter N, capital letter N. Or it can be a capital letter and a lowercase letter. So like calcium is Ca, uppercase C, lowercase a. Most elements, their symbol is just like the first couple letters of their name. There are a few exceptions. Like copper, C-O-P-P-E-R, the chemical symbol for that is Cu.
See you later.
So there are other elements, like you might notice that the element potassium, it's way over on the left in the periodic table, is the symbol for that is K. Where do we get K in potassium? We got that from the old Latin name for potassium, and that's Kalium. Another couple interesting ones are gold is Au. This chemical symbol for gold is Au. For the old Latin name aurum. And silver is Ag for argum. Now, you might even notice that there's mercury is Hg. That's hydroargum. That means liquid silver. So, and if you ever see mercury, mercury is a metal, but it's a liquid. It's a liquid metal. It's very interesting. We don't really have too much of that anymore because it is hazardous to contain and hazardous to dispose of. So, I'll let you guys finish this up. Every substance has a formula. The formula contains the following information: the elements present in the particle, as well as the number of each element in the particle. You guys don't have to copy down what's in parentheses. So copy down what's not in parentheses here. So every substance has its own unique formula. In that formula, you can tell the elements present in that substance, as well as the number of each element in that substance. The example I gave is potassium sulfate. The formula for that is K2SO4. So we can get the information that it's made of potassium atoms, sulfur atoms, and oxygen atoms. We can also get the information that this particle is made of 2 potassium atoms, 1 sulfur atom, and 4 oxygen atoms. If there's no subscript like there is under the S, we understand it as 1. So you can also think of that as K2S1O4. Okay? So if you want to write that in, I'm perfectly fine with that. But normally I'm going to write it the usual way, K2SO4. But if you wanted to write a little 1 there, that would be fine. Moving on. So another example is this substance, copper nitrate, copper 2 nitrate to be specific. So the formula for this is Cu parentheses NO3 close parentheses 2. If something is in parentheses, that subscript distributes to what's inside. So similar to math, if you have like a 2 outside of parentheses, that means you have 2 of whatever's inside that parentheses. In this case, the 2 is on the parentheses outside the NO3 group. So it means that there are 2 NO3s. So in NO3, in just that, there's 1 N and 3 O's. If I had 2 of those, it would be 2 N's and 6 O's. So overall in this compound, Raffi, look up here. There's going to be 1 Cu, 1 copper atom, 2 nitrogen atoms, and 6 oxygen atoms. So you can look at the formula. Remember, if there's no number as a subscript, we assume to be 1. Okay? So these are also a few things that we use in communicating chemistry. We use symbols to represent the different phases or physical states. So we can also use other symbols as an easy way to communicate what's going on in a reaction. Oops. So, for instance, these are some common symbols we use to describe the phases of matter, or sometimes that's referred to the physical form or physical state. So what we use is, we use S to indicate if a substance is solid, L to indicate a substance is a liquid, or G if substance is a gas. AQ is also used commonly to say that it's in solution, an aqueous solution. Aqueous, you might recognize the root of that word, aqua, meaning water. So an aqueous solution is just to say something's mixed or dissolved in water. Okay, we'll pick this up in a little bit.